unprecedented. This last one was the real one. This was a tropical disturbance out there. Some kid in Texas put out a 14-day forecast that brought it right up here. People, for Irma, you know, it was Harvey, Irma, Maria, all those. This sent people, I mean, people were panicking down in Texas. It was shared over 30,000, 23,000, by the time they got this off of Facebook, 34,000 shares. Why do people share the fake stuff when the real stuff from our webpage, we get 12 shares?
Sarah said it's not fake.
What's that? They said, oh, there we go. It's not fake, it's true. Yeah, okay. So who can you believe? Are we going to have, you know, is it all rosy, or is it, you know, death, gloom, and doom? It's all about your perspective. Everybody agrees we've got, you know, gray and white blocks there, right? Well, do we really? Well, they're just gray. So this is the black and white thing. I can't, oh yeah, this is what I did. I actually used to stop and do it. We have a black box here. I created a nice little video. Does it work? Okay, so if you change the brightness from 0 to 100, you go for a black box or a white box. Black, white, black, white. Or if you slow it down and look at the many shades of gray, guess what? There's a whole world out there that the right, wrong, black, white, left, right is not seeing. And as I like to say, the right place to be is somewhere in the middle, unless you're on a 2-lane highway. That's not a good thing. But the real answers are not the things that are being hyped. Hype is black and white. What's that?
You gotta teach philosophy.
Yeah, exactly. Well, yeah, I didn't think I was, well, I used to say that, you know, when I was in high school and college, political science was the science of studying politics. Now, political science means you base your science on which political leanings you have, so. Reality, hype is black and white, reality is many shades of gray. That goes with climate, too. The truth, with climate hype, we can control our planet's temperature. You know, this is what I was talking about before. No, we're parasites on the planet. You know, we're those fleas on the butt of the dog. The black hatters are saying, mankind has no effect on our weather and climate. There's nothing to be seen here. That's not true. We're one of many factors. Just one of many. But we do definitely have an effect on our weather and climate. This is the temperature, this is the land use in the city of Louisville. Red is asphalt, developed high intensity out in the burbs. As you get farther out, these are the temperatures, overnight minimum temperatures for one of mine. This is, my house is one of these 78s. 83 degrees at the airport, 78, 78, 76. This is inside the Snyder. So that's not very far out. 7-degree temperature, just going from the heart of concrete city right here, because there's no grass around, to somewhere over in Middletown. Or, you know, I don't know, what, that area. And it's a fact that hot air rises. In fact, when I first moved here 11 years ago, I used to be a hot air balloonist when I lived in Wyoming. I did talks for the first couple of years for the Balloon Society of Kentucky, their weather safety conferences. They always have a meteorologist come talk. I haven't done it for a couple of years. I've shared it with other people in the office. But the reason that we have clouds form is because hot air is rising and doing that. But when hot air balloonists are trying to fly, they fly down here and they follow the average winds. And what happened in Louisville was that, or the prevailing winds, what has happened in Louisville is the city is heated up so much that the air that's coming in around it, they used to take off near, well, they can't now because there's a big Target and stuff out there on East Shelbyville Road near the Snyder. But they used to be able to take off from an open field out there and go out to Simpsonville and land somewhere near Simpsonville. Now they can't. They said that this was 11 years ago. They said, we can't do that anymore because every time we take off, we get sucked into the city because that's the prevailing wind flow is to go into the heat generator. This is all convection. So this heat island that's been caused is not just one temperature point at the Louisville airport. It's a real thing. And it's really causing, it affects weather. When I was out in Wyoming, putting well, they dammed up the North Platte River, and you dam up part of the river and you get a lake there. Well, guess what? That's a heat sink. You know, the sun hits it, you don't get any clouds above you get clouds above the land nearby because they're heating, and it's cooler, and you get a breeze. It's like a lake breeze, like an ocean breeze. So, you know, that was man-made. So we do have effects on our weather. There's the example. This is the same night that we were looking at August 4th, just a little cruder look at it, 76, 76. So right here, you're going to get air flowing in from all directions when it's a real weak pressure gradient. Now, if there's a strong pressure gradient, that's a different case. But hot air balloonists don't fly in strong pressure gradients because they can't fly in strong winds. You have to be 6 miles an hour, 6 to 7 miles an hour peak wind to inflate the balloon and land, ideally to land in. But you're always going to be coming up here, so everything. So now they got to go clear out here to fly out. So, and that's been going on. This guy said 25 years ago we used to take off right here and go out. 11 years ago they couldn't do it anymore. No, that's me being cute. Oh, I guess I have to be on that. Oh, some other ways we affect. This was our neighboring office up in Wilmington sent this out. My son actually worked at this. This is the Miami Fort power plant on the Mississippi, or on the Ohio River, just outside of Cincinnati. And they sent out something one day saying how the stacks were releasing all this moisture, and that caused snowfall over here because it was just the right conditions. It had high enough moisture content, the temperatures were right, and there was cloud cover. So it was basically cloud seeding is what it was. It wasn't, you know, pollution necessarily, because my son knows, he's a mechanical engineer, how much they scrub the, you know, stuff to get, you know, down to meet the EPA standards. And with our new satellite, we have a really nice new satellite, the GOES 16, GOES 17. It's incredible, the resolution and the stuff you can see. This is the nighttime cloud physics, and was able to go through and identify, it doesn't look as good on here as it did the original image, but we identified every single one of the coal-fired power plants here where the conditions were right, and all of these were producing snowfall. We had a case that happened here in Louisville a couple of years ago where the airplanes caused it. They were kicking up you know, stirring up the air. Just get the vertical motion in the right conditions. You can see right where the winds came in. So we're working with UPS now that when this sort of stuff happens, we'll talk together and we'll contact the transportation cabinet so that they know, because what happened in this case was there was a bunch of snow that kept falling. We actually put out a snow advisory. You can see it there. It looks more like a severe thunderstorm warning. Real tiny snow advisory for I-65 down in Bullitt County. And they had, you know, 1.5 inches of snow on there, and that caused some accidents. So there again, this would not have happened without airplanes flying there. And man-made weather, you know, Frank Capra knew it in 1946. See, because George wasn't alive, there was no plastics factory. So, you know, the plastic factory that Sam, his buddy Sam put there, didn't exist. But when he came back to life, it starts snowing again. See? You know, we've known this for 70 years, you know? All we have to do is look to Hollywood for the answers. I put that in there because that's my favorite movie. Okay, so reality check. I like quotes. This is the whole quote, but this is my favorite part of it. There are known knowns and there are known unknowns. There are also unknown unknowns, and it's the latter category that tend to be the difficult ones, which is true. You know, we can prepare for things, you know, if we know we're being blindsided by something, that's different than not even knowing, you know, that something's out there that's going to affect us. So when it comes down to climatology, there's no way you can model the unknown unknowns. Okay, so what contributes to our weather? Well, Everything is cyclical. We have the annual cycle. It's warm in the summer, cold in the winter. We have the monthly diurnal, or the monthly lunar cycle. The moon has an effect. If you don't think it does, just look what happens at high tide, low tide. You don't want a hurricane making landfall at high tide. There's a lot of water, extra water, slapping up on the shore. Then you have your diurnal, warm in the day, cold at night, warm in the day, cold at night. The different amplitudes and the different periodicity, and you start throwing all these things together in different things, and you get this nice little trace like this. What's that? And so, El Nino Southern Oscillation. Yeah, sorry, I told you, you might have missed this. I said that NOAA, we're part of NOAA, the National Oceanic and Atmospheric Administration, also known as the National Organization for the Advancement of Acronyms. So we use a lot of acronyms. Okay, so El Nino, and so warm water on the in the Eastern Pacific, it has an interaction with our atmosphere, and hot air tends to cause the air to expand above it. Cold air causes it to contract. The sunspot cycle, we all know there's an 11-year sunspot cycle, right? 22 years if you take into consideration that the poles reverse every 20 or every 11 years. But you can see that even on the sun, there's different amplitude, or there's a cycle of high amplitude, the extent of the high amplitude years versus low amplitude years. And this is what I was talking about earlier, the Maunder minimum, 17th century, the mini ice age in Europe. Okay, so what else? Yeah, pollution affects it. There's the big thing, the population going from 1 billion in 1850 to over 8-9 billion wherever we're going. Traces right along with our carbon dioxide.
Science has got a stunning view of an active volcano in southern
we can't control this.
It is erupting under an ice sheet,
and that's all heat.
It could actually trigger
this
a large
under the planet, or under the mantle, comes up, and when I lived out in Wyoming, I had a friend point out that the big caldera in Yellowstone is a giant volcano. It's great. All that geothermal activity. Supposedly it's 10,000 years overdue to blow. Said where I was living out there, said you'll be under 20 feet of ash in about 2 minutes. So that was always nice to know. So I'm a little farther away now. Okay, so cause and effect. Domino effect. This is one, I love this. Does anyone else not see a cycle there? But we get these straight lines. Remember, lies, damn lies, and statistics. Okay.
But the cycle is trending up, right?
Yeah.
So the line is showing that.
But is this cycle
lower left to upper right?
Yeah, but we don't know if this is part of a bigger cycle.
It may be, but it's not the stock market, right?
Right.
So, stocks, you don't want to predict it. Do I here?
Exactly.
Here, right? Because stocks are unpredictable. Climate, long-term climate.
Yeah.
Unless something major happens.
Yeah. And look at what we're looking at. It says 1880 to 2004, but this is the latitude range of 70 to 90. Do you know what latitude we're at? 38 degrees down here. So let's look at some data that's a little closer to us. Wow. Can't argue with that, can you? Imagine it's pretty darn close. But I can't explain, well, no, there are some, it's not very good right there. But I can explain that because, see, this was Eddie Sutton's NCAA probation, and that was when Tubby, see, those are UK basketball wins. Yeah, so, so what I'm saying is, you got to be very cautious when people start throwing charts up there, because you can, statistics, you can twist them any way you want. I can take the same statistics and twist them to be far right or far left. So you have to look at, personally, I believe you have to look at the motivation behind who's showing you the statistics. I'm not going to, I'm retiring in 2 years and 3 months. Doesn't matter to me, what. Yeah, who's counting exactly? I am counting. No, surprise, surprise. No, but somebody's going to come in and do the job after me. I've given 32 years of my life to protect lives and property. And I do, that's why I get very passionate about things like flooding. Stuff that, I'm passionate about not polluting the planet. But I don't know the answers on that one. I know the answers with some flooding. Don't drive into flooded roads, But we've got people who don't have any any experience, any knowledge, talking as if they're experts on things that, like, won't come to fruition for 30 or 40 years. Now, do I believe we should ignore them? No. We should do what we can.
Hoax.
What's that?
It's not a Chinese hoax, just to ignore it.
Yeah. Well, but, and then, things that we think we know. How many of you remember...
The field of science will not exist if we wait to know everything.
Right.
We have
Exactly.
to make assumptions.
Oh yeah, and when I said that we can't wait to find out, that's when I was accused of being a climate change chicken little. It's like, no, you don't just sit and wait for it. You do what you can. You try to minimize your impact.
Donald Rumsfeld was justifying Iraq invasion by saying that quote, and it's very misplaced to quote him to make this argument
Oh
that
yeah. Well,
we don't have.
Yeah, no, I'm not. No, I'm just saying that as part of an argument for not, that there's uncertainty that's out there, But I don't think we should not do anything. I think it's completely stupid to, to pull out of the Paris Accords and not do anything. I mean, that's just foolish.
They say like all models are wrong, some models are useful because they save life. So that what happens next hour, you cannot really accurately predict. Then why we have all this?
Right. Yeah.
So because we have to make some adjustments.
No, I don't disagree one bit with you, but what I disagree with is people who like to imply that somehow we can crank back the thermostat. We can't do that. We can't turn it back to, there's no MAGA of, I want it to be just like it was in the temperatures in the 1920s, because the 1920s were a great decade. Well, how do you know we're not going to do something that makes the 1930s, the Dust Bowls, I mean, every action that we have causes some other reaction. That's the whole idea behind the butterfly effect.
Yeah.
And we don't know. We can try to fix things. Managing nature that's the biggest oxymoron that I've ever heard of. You can't manage nature. You can deal with it.
But as you said, like not polluting our home is not a thing that we should hesitate to do. Like.
Oh yeah, I drive a Prius. I try to, I do it because mostly because I was so sick of the gas prices in Louisville. But I also didn't want to pollute our planet. So I get 49 miles a gallon going back and forth to work. If I could ride my bike, I would. But it's 12. It's 21 miles one way. I'm not going to ride for 3 hours to get to work. So, but let me see. Oh, here. This is my my little demonstration of how you can't change one thing and expect everything else. I found this one on the internet. It's some college students or high school students, video thing. It's a little too long in my opinion, but.
Chaos theory states that the flapping of a butterfly's wings creates tiny changes in the atmosphere that may ultimately result in a tornado. These same effects can be observed in our own lives. The smallest variations in our day-to-day actions could result in major changes to our lives in the long term. One seemingly insignificant action you took many years ago may have changed the course of your life and made you who you are today. Your life right now could be very different for you had you not responded to a job ad. If you hadn't plucked up the courage to ask your partner out on your first date. If you hadn't stood up for yourself in a fight in town. Or if you left home 8 seconds later this morning because you stopped to pick up the post.
This is where it gets a little long, a little tedious. Come on, come on.
The dinosaur's gonna get it.
It's Groundhog Day, yeah. Oh, we picked up the mail, yeah. Yeah, just sped this up a little bit more.
Amazing.
I'm sorry, I just think that is so funny. Especially since you see the shot of him walking out and there's no car there. And all of a sudden he gets, and evidently that guy, whoever person that drove the car must have changed something too, because he walked down the street before, you know, it would have been during that amount of time. So, but most people, some people don't appreciate my humor, but some do. Okay, so let's take a look at where weather and climate are equal. Weather is always changing. Climate is always changing. If it hadn't changed 25,000 years ago, before any impact by man of any amount that we know about, my hometown would still be under 4 miles of ice in northwest Iowa, because that's the depth of the glacier that's been estimated for where that was. So it's always changing. It's cyclical and periodic. Climate is cyclical and periodic. We have many contributing elements. Some are known, some are unknown, and mankind is definitely one of them. Same with climate. We have many contributing elements. Some are known, some are unknown, and yes, we are definitely one of them. Don't say that we're not, because that makes you sound stupid, because we already know that we've affected it. Okay, where are weather and climate not the same? Well, weather's easily tracked and measured. Climate, it's difficult to track and measure. Why? Weather is easy because standard observations of finite parameters. I can measure the temperature, pressure, humidity, precip, wind, clouds, plot it all on a map, and I could draw you a weather map. With climate, well, we've got inconsistent observations of various parameters: carbon dioxide, sea surface temperature, sea level, glacial area, et cetera, et cetera. Some of these records, you know, satellite records only go back 40 years. You know, some others go back a lot longer. So we've got a lengthy database when it comes to weather, because when we look at weather as a daily thing, so we go back 150 years. That's a long database for weather. But we have a really short database when we're talking about climate, because 25,000 years ago, there was 4 miles of ice over my hometown. We don't know why it went away. We don't know what caused it. So, other ways that it's different. We've got proven computer models for weather. Verification, hours and days, that's why they're proven. We know if they work or they don't. With climate models, they're limited and untested. Why? Because verification takes decades to years, or years to decades to centuries. A spatial and temporal resolution is improving with each generation of our computing power. The computer models that we have now are head and shoulders above what we had when I joined the Weather Service in 1987. There's just no comparison. With climate models, we have numerous variables that are treated as constants, which makes them suspect, and which makes them, the uncertainty not go away. And when we say that we're certain about things, I can say, well, yeah, doctors, 400 years ago were certain that if they put leeches all over you, they'd, cure whatever ailed you. We don't do that anymore. So certainty when it comes to science it's really sort of a fallacy. Okay, so what does it all mean? Forecasting weather and climate especially for a specific location. Now, climate, you talk about the globe. Yeah, we know the globe's warming up. We've got evidence of it. But what is it going to mean for Louisville, Frankfurt, or Lexington when we run those models and say it's going to be 10 degrees warmer here in 12 years? No, that's one model. That's what one model says, or that's what we've discerned from the variation of models. So, most important, don't expect to control our climate. We can contribute positively or negatively. We cannot control our climate. And I will defend that statement to anyone who wants to argue with me. We cannot control it. Do try to impact the environment as little as possible. Leave it cleaner than you found it. It's not rocket science. Pack it in, pack it out. If the Boy Scouts can do it, all those Boy Scouts who grew up to be CEOs of major corporations could do it too. Okay. That's where I go into my spiel on that. So, hope I didn't make anybody too mad, you know. But I mean, the answer is somewhere in the middle. You know, it's not on the far right. It's not on the far left. It's somewhere in the middle. And you know, personally, I think that's what's wrong with politics in this country right now. Is there's nobody in the middle. You know, we're all wackos over here, wackos over there.
Very complicated stuff. You can't just learn about it in one paragraph of an article. This is very complicated. Like all the scientists that I talk to that are in different areas have totally different views on it, and they're like, it's complicated.
Oh yeah.
Everything's so interrelated. And I think it's really hard to have a discussion.
Well, and I think honestly, I got my social media accounts before the office did because we were so slow on getting up there. So I was doing all this sort of stuff, and because I had to counteract what people were doing, sending out those fake hurricane tracks and stuff like that. And now that we're on there, it's like so I mentioned social media has become antisocial. It's so easy to get on and just rant. And anybody can rant, and it's just I don't know. I don't think it's a.
I would just say for like when I deal with groups that are, whether it's like students or people who aren't as knowledgeable on these topics as yourself, that erring towards complexity or middle ground, I think can be maybe a mistake.